So,
thank you very much. So the talk is, what makes Python so awesome? I could have put a period here, an exclamation point, or a question. I'm going to try it all three different ways. So, quick introduction. I'm a PSF board member. I decided to become a board member after getting a really good massage. Long-term Python core developer. I've written some of the tools that you probably use every day, set objects, sorting key functions, iter tools, that sort of thing. But the most important part of this is the Raymond H on Twitter. If you are connected in now, what I'd like to do is make this a very dynamic and a fun talk where you guys are, as we're going along, tweeting about what you think makes Python awesome. I'd like it to be a two-way conversation, and so let's all share as we go along. So I think that makes Python awesome. I have something that's not on the list that I think is Python as awesome, and so either tweet it to EuroPython or at Raymond H. Also at Raymond H, I've for the past couple months tried to put out some Python tips and tricks, one or two every day, to try and create an interesting two-way, fun Twitter feed. Okay, so I have a question for you. Name an awesome language.
Python.
I've heard a couple things. Any others?
English.
Okay, I've heard Python mentioned a number of times. Who said Python? Why is it awesome? You can read it, so that makes it great. What else makes it great? Does everybody here agree that Python is awesome? Okay, we seem to have general agreement. Are there any other awesome languages? It is my opinion that all of these are awesome. I have programmed in all of them at one time or another, and they each have their own degree of awesomeness. Assembler was great because it was close to the middle, and I could, back when memory was constrained, fit lots of stuff in a small space. COBOL was a little less awesome, but there is a reason that there have been billions of lines of code of COBOL written, and there is a reason that Fortran is still around. All of these languages are awesome in some way, so I'm not here to convince you today that Python is more awesome. Instead, we're going to talk about the things that does make Python awesome itself. Each language is awesome in its own ways. What are our ways? We've come up with one, which is our readability. Is there anything else that makes Python awesome? That's a really good one. That one wasn't on the list. Remind me of that, and we will come back to that. It's fantastic. Anything else? Already covered? You guys have not guessed the next slide yet. The thing that makes Python the most awesome is its license. Okay, actually what I've done is compile a list of reasons I think that Python is awesome, starting from very high-level contextual factors, then going to some high-level use of the language, and then some actual language features itself. So those are the three parts of the talk. So what it took to get Python on the map, I think one of the most important things was its license. Had Guido not open sourced it, you would not be using Python today. Being open is at the heart of what makes Python awesome. Interesting parts of the license are it's available to you on an as-is basis. Does that sound awesome? Like, if it breaks, it's not our fault? That part doesn't sound as awesome, but we give you access to the source code. The most important part is the last part. The owners of the intellectual property rights, the PSF, they grant you a non-exclusive, royalty-free, worldwide license to reproduce, analyze, test, perform, and/or publicly display, prepare derivative works, distribute, or otherwise use Python alone or in any derivative version. Who thinks that's awesome? It is awesome. That's why we use Python today.
It's also great that the PSF owns the copyright, and that's not some copyright.
I concur. Python is awesome because it has commercial distributions. This is a very short list, but the list of people working, commercial firms working in the Python community is enormous. But these are two separate commercial distributions. Why is that awesome? I contend that a language can't be successful until it has some commercial distributions. because there are companies that unless there is a commercial distribution, they can't use it. And so these groups sell to people who need a commercial distribution, and we have a language that encourages the commercial side as well as the free and open side. The two fit together really nicely. I think it was a key factor of success. So if you're everything should be free and open person, realize that the commercial side of it was contributed to some of the success to get us where we are today. What else do we have? What makes us special? We've got Zen. It speaks for itself. We've got more Zen. And as was mentioned, we've got the community. I think community is one of the killer features. Someone asks you why Python is awesome. In part, it has a fantastic community. We have the news groups, the mail list. There are PyCons everywhere now. I just got invited to go speak in India, of all places, so that'll be my first trip there. They're popping up all over the place. There are Pi interest groups everywhere. The language is having a phenomenal success, and part of it is the community of people. You are the folks that make this make Python wonderful to work with. Who thinks the community is a killer feature? So if you're making your own language and you want it to be awesome, one of the first things you need to do before you write your first line of code is start to develop a wonderful community like we've got today, one that scales and retains its nice qualities and is pleasant to work with. We've got Pippi. Why is that important? It's our way of exchanging modules with one another and work with one another in a way that's easy to use. Currently up to 15,000 package. It's directly accessible by installers so that you can go in and say, pip install order dict, and even if you're working in Python 2.5, the order dict will come right down and you can start working with the features that were introduced in later versions of Python. I think Pippi is a killer feature. What do you think? Okay. I see some nods of affirmation, but I don't see fingers typing, tweeting up a storm saying, yes, the community was... No, it's Pippi. I insist that Pippi is our killer feature. Okay, if you're going to have a successful language, what else do you need? You need killer apps and success stories. Once again, this is not an all-inclusive list. Zope, why is it on the list? Because it was early and big. It put Python on the map in some ways. It was every bit as important to Python as Django and Pylons are today. How about NumPy and SciPy? There's a whole section of the community that works with these tools every day. BitTorrent was written in Python. Twisted is a fantastic tool. YouTube, I understand, was at one point entirely based in Python. We have Google's acceptance of and use of Python, I understand, was one of the big reasons that Python became more accepted in Japan. When Guido joined Google, that in and of itself boosted the success rate in Japan and changed the perception of the language as a whole. So we're talking about high-level context factors, things that contribute to making Python awesome. You cannot have an awesome language without some killer apps and some big success stories. 32. I'll bet most of you in here don't use Windows. But there's a huge, huge, huge segment of the world that does. Who opened our door to that? That was Mark Hammond. He opened up a massive, massive user base. Without it, Python would not be where it is today. So we're all benefiting for tools that we might not even use. You may have never heard of Zope, maybe never used Zope, but you're benefiting from the community that was formed by Zope, the massive number of users who came to Python from Zope. Likewise, you are benefiting now from the enormous number of people who got benefit from being able to run on Windows and interface with the Microsoft apps. And we've got books. We've got a number of book authors here. There's Learning Python, Dive into Python, Python in a Nutshell, Python Cookbook. Hey, you've got two of them on here. That's not fair. Okay, and an upcoming book. What makes the last book special, besides being vaporware at this point? Okay, the last book is special because it is written by you. We have gone out to various members of the community, asking them to write about what they were expert in. So most books are a bit of a challenge, even for Alex Martelli, to have to write a whole book about all of Python because it puts him in the position of having to be an expert about every single corner of Python. The different approach for Python swallowed whole is we actually went to the expert person who wrote the decimal module, person who created module X, Y, or Z, the person who's or the group of people who worked on Jython, for example, and said, write us a chapter, tell us what we need to know, educate us. So it is a book by the community. Every chapter was written by the expert in that particular area, and I think it's going to be a fantastic thing. Where do 100% of the proceeds go? To the Python Massage Foundation, Python Software Foundation. All right, so summary. This is what you need as a context for success. You need a good license. You need some commercial distributions. You need the Zen. Without your philosophy, you're not centered. You need a community. All of these things are necessary if you're going to get your language up and running and make it awesome. You need to run on Windows. You need to have some success stories. And you need to have a few good books out there. There are some languages that I think are pretty neat, some tools I think are pretty neat, and there are no books on them. It makes them relatively inaccessible to me. I think all of these are essential success factors. Who thinks all of these things make Python awesome? All right. Let's go down a level. That was just too high level for me, Raymond. What, besides context, are we doing right? Name something specific to Python itself, because all the things I just mentioned really could have applied to any other language. And yet you guys said it was Python that was awesome. So what else are we doing right? What are some of the qualities of Python itself that make it distinct? So I think that's last on the list today, and that is a detailed language feature, as opposed to right now we're at the middle level, the qualities of the language. I tried to rank order a couple of these, and I thought put ease of learning on the top of the list. In order to get ready for this talk, I went to a number of clients, I've taught a number of classes, and I've surveyed them all and asked them what makes Python awesome. And one of the amazing features is how quickly you can get up to speed with Python. It used to be you could learn all of Python in a weekend. Now it's a much bigger language, but the core of Python can be learned very quickly. What can be learned in 1 hour? You can learn your types, int, floats, string, list, tuples, sets, dict. Those are enough to get you very, very, very far in algorithm design and solving your problems. Learn the control structures, for loops, while loops, try, except, if, then, else. And then you've learned some tools to organize your programs into functions, classes, and modules. I can cover that in 1 hour in a high-speed class. Now, in that 1 hour, there won't be a whole lot of time for practice and whatnot, but I have seen tutorials that can walk you through in 1 hour and cover all of those subjects. I think that's amazing. Who thinks they can get that far in C++ in an hour? I actually participated on the C++ standardization committee many, many, many moons ago. And yet, I've still yet to master that language. And I think that says something. What can be learned in a day? Well, if you've got a day of training, you can learn Python idioms, you can learn all the common methods on common objects, you can get a tour of the standard library so you know what's available, and learn the special methods. In other words, you're decently well equipped after 1 day of training to start writing Python programs that are useful. Who thinks that's fantastic? It is one of the killer features of the language, and I think it's one of the number one things that makes Python awesome. I don't get asked this as much anymore, but a few years ago, a common question by businesses was, where do I go to get Python programmers? So just starting a Python program, I'm not going to have my business use Python because I can't get Python programmers. I look in the listings and I don't see them. Where do Python programmers come from? And I'd always answer, take any good programmer, give them a week-long training course, and they are a Python programmer. It takes that long to get productive to a commercial level in Python. How long does it take to get that productive in Java? I'd say after 6 months, a person can be a pretty solid contributor as a Java programmer. And after 2 years of C++, they can be a pretty solid contributor. If you are already a good programmer, I can get you there in a week. Who thinks that's fantastic? It's a reason to base your business on Python. I don't have any Python programmers. Went into a business that didn't have any Python programmers, conducted training for a week, and guess what? They have an army of Python programmers. You can make them out of nothing. Who thinks that's fantastic? Who thinks that's awesome? All right. So I think it's one of the number one attractions to the language. Then there's the rapid development cycle. And there are rapid development methodologies that can be used in any language. And one of my first exposures to rapid development was, I was a big fan of the programming language awk. I wrote a flight simulator in awk. This was in the category of scripting languages. Scripting languages are just hard to beat for speed. Programs grow up organically. They're always working, and you're just grafting on new functionality. It begets a style of development that's fantastically productive. It also has this really nice environment for us where, with the interactive prompt, it lets you write a function and then immediately go out and start working with your own tools. And that doesn't seem like a big deal unless you compare it to languages where you can't do that, where you have to build up an enormous library. And it's not. It didn't used to be uncommon to go into an organization and see them do a tremendous amount of development, but have never actually worked with their own tool. They didn't see how the parts fit together. They saw descriptions of how the parts fit together. They whiteboarded it, but they couldn't go out and actually play with their tools. You take your average C++ library or C library, you have to graft on a lot of tools in order to be able to go and play with each of the pieces you've just made. But in Python, it's remarkably easy to do so. This is not the only language that has that. Smalltalk was fantastic in that you could graft on a little piece of functionality and exercise it right away. It leads to very rapid development. And then, of course, interpreted languages save your cycle of edit, compile, and run. I don't think that's a particularly killer feature because with Make and with some other tools that are available in compiled languages, that is not that big of a step. The more important thing is being able to work interactively and growing organically. Who thinks rapid development is Python's most killer feature? Interesting. It is such a killer feature that it can overcome some of Python's limitations. Compared to some compiled languages with well-designed code, Python is ungodly slow. And where would that matter? That might matter in a genomics field where you have enormous data sets. I worked in a high-frequency trading company where we wrote strategies to go out and find momentary aberrations in the stock market and arbitrage them away. Those aberrations could last for under a millisecond, and the early bird gets the worm. Whoever had the fastest program would win. So why did we program in Python? I went to a genomics company. We programmed in Python. Why? If Python is so slow, the answer is the rapid development cycle more than makes up for that. The ability to, in a trading firm, to adapt a strategy as fast as the market is changing. So, if you were programming in C++ or Java, you don't typically have conversations along the lines of, hey, the market dynamics just changed. Can you make me a new program right now, and half an hour from now we'll run it live on the market and start trading with it? Very few other languages have the capability for that sort of response time, and I think it's one of Python's killer features. Who thinks that's awesome? All right, tweet it from the mountaintops. This is one of my favorites, economy of expression. The code that you see here is the refined version of the answer to an early exercise given a training class. So we have people write some very dirt simple Python that does exactly this, and it's designed to show off some of the libraries and to show off iteration protocol and that sort of thing. And it has a subtext to it. It's designed to convince people that Python is powerful. They have written one of their first programs that is more than a one or two liner, and then find themselves, what's the European term? Gobsmacked. Gobsmacked that you could do so much with so little code. But the thing I like to do is after they've written that, we come back and we refine it a little bit more, throw in a couple more advanced tools. And then the punchline of the exercise is where we go back and compare it to the English description of the problem. And we find that the Python code is clearer than the description of the problem. It's more terse and more succinct. And more importantly, there is a direct correspondence between the words you use in the problem specification and the words you use in Python. So, starting from the top, I am giving someone instructions on what I want them to do. Our overall task, by the way, is we're going to analyze some log files to see which resources are most commonly hit on our web server. So, here are my instructions to the person. I want you to set up a tally sheet so you can start counting. That's what that first line says. Set up a tally sheet so you can start counting. Now, I'd like you to go to the data logs directory and find all the GZ files and loop over them line by line. That's what the second line says. Keep in mind, I used more words to describe it in English vaguely than I did in Python, where I described it precisely. The words in English, again, were go to the data logs directory, find all of the files that end with .gz, and loop over each of those file names. Now, those happen to be gzip files, so I do a gzip open. So open each file, gzipped, and loop over it line by line. That's what the third line says. Loop over line by line a gzip file. That's a lot of economy of expression. It took, 6 words on that line. Precisely describe what is taking place. Now, once you've looped over all the lines in the log files, I'd like you to search each line for something that starts with a GET, ends with an HTTP, and has something in between. If you find it, if that's not none, then consider that group to be a URL. So the URL is located between the GET and the HTTP line. And once you've got the URL, count it. Counter URL plus equal 1. Now take that result and give me the top 20 hits treating the count as the sort key. That's all the code it takes to go out, hop into a directory, loop over all the log files, read the gzip log files. You don't have to unzip them. Just read them directly, effectively grep over them, extract a piece of data, count them up, tally them, sort them, and take them to top 20. And it's actually remarkably efficient. Who thinks that's fantastic? That is economy of expression, and more importantly, the words here correspond very closely to the words in the business logic. I can take someone through this program who has never programmed in Python before, and they walk away reasonably convinced the program did exactly what I said. I cannot do that with the COBOL program. I cannot do that with APL, which I loved APL, but I couldn't do it with it. I couldn't even do it with Excel. And Excel was designed to lay out thoughts in a fairly clear pattern, but it didn't describe looping idioms very well. Who thinks this is fantastic? Economy of expression is one of the things going for the language. I think we've made it as economical as possible without venturing into the land of unreadability, as was done with APL. Okay, beauty counts. So one of the things that was mentioned when I said, why is Python awesome? And the answer is readability. You'll hear people mention this all the time. Python's very readable. Why is that important? Beauty is important for the programmer because it makes the language joyous to use. Languages that aren't pretty, even if they're expressive, even if they closely correspond to the problem domain, are not as fun to play with. Even if you're good at that style of expression, like I really enjoy working with MATLAB, I'm reasonably proficient expressing problems in terms of matrices. But I have to say, MATLAB programs aren't beautiful. They are succinct, and they correspond very nicely to the mathematical notation, but you don't feel the same joy as you get when you look at a program like that, which is just so clean and just rolls off the fingertips as you write it. So joy, I think, is one of the reasons that attracts us to the language. But from a manager's point of view, or a company adopting Python, the readability counts is absolutely essential. It's why they've come to Python and given up all of their bash scripts. Why would I devote hundreds and hundreds of man-hours to having someone rewrite all of my bash scripts in Python? The thought is I'm trying to get something for that. And what I'm getting is the readability so that I'll actually be able to maintain those scripts. And readability is fine for yourself as a reminder. It improves the joy of the programming, but it's particularly nice when you get to maintaining someone else's code that you have some fighting chance of being able to read it. So one good argument in the favor of that is Python ships with its own source code. So you can open up the collections module and go down and criticize my coding style and say, Raymond, I would have never done it this way. Or, my God, that was a nice piece of code. It's all out there in the open, and it's pretty easy to read, and it's an educational effort. So I recommend highly reading a little bit of source code from the standard library. It'll make you a better programmer, and it will certainly drive home one of the benefits of readability. The assembly language didn't have that. So I would go back and look at someone else's assembly language code. The process of reading that code was really an act of decryption. Now, to be fair, a good assembly language programmer designs, procedure names, and comments and whatnot to try and decrease the effort. And so assembly language programs can be written in a readable fashion. It's just they often weren't. So in the hands of a good programmer, lots of languages can be made readable. Python just seems to come out that way, even from bad programmers. Who thinks that's a fantastic feature of the language? It is one of the number one draws when you go around and ask people what makes Python awesome. Now, one that's not mentioned much, but comes up when I really drill down and ask people, why did you come to Python from Perl? What made it better? And it's the one way to do it. If you've started programming in Python and hadn't worked with a language like Perl, it's hard to appreciate how could things be any different. Isn't this just the way you would code? And the answer is no. Perl and Ruby both share a philosophy of many ways to do it. They actually consider that to be a strength of their community, and in their own ways, those languages are awesome. Our awesomeness is that we've chosen to go on a different path. And so in Perl, there's often many different idioms that can be used, and people fall into a style. I do some subscripting into array that indexes into something else, and I've created my own little mini language with my mini idioms. And other people who program like me can read my code, but there were other paths to go down. And as you compare two sets of Perl programs written by different teams, they are so different that it becomes a write-only language. That the team that wrote it can read it, but if they go over and look at something in someone else's style. This is particularly a tough problem for Lua. Lua ships with almost no batteries included. Lua is an awesome language. It is lightweight. It graphs onto C. It is the easiest way to graft a scripting language onto C. So don't get me wrong. It's awesome. But it ships with so few batteries included that one of the first things you have to do is re-implement object-oriented programming. They give you dictionaries that train to one another, and they give you a dot operator. After that, you build your own. And not everybody builds it in the same way. So you quickly build your own language on top of Lua, because nobody codes in just Lua that's naked. It's always a building up of the libraries, and everyone does it in a different way. Meaning that if you come to someone else's Lua code and have to maintain it, you have to recreate their whole thought process from the ground up to rediscover the language that they invented. One way to do it is a killer feature of the language, and yet if I survey groups of people, for the most part, it never comes up until we get down to brass tacks and really start interviewing and say, why is this better than what you were coding 10 years ago? And let's compare the same programs written in different language. It's a killer feature. Who thinks it's awesome? Okay. We've got an interactive prompt. One of the neat things about this, I like to tell classes when we're starting, Python experts don't memorize Python. I will sit down and talk with Alex, our Guido, our Brett, and as we discuss the language, we rediscover for ourselves what it does, and we fire up the interpreter. It's possible, even Armin goes to the interpreter, rediscovers what it does. I think it's a fantastic tool, and you don't miss it. You don't realize how significant it is until you go to another language that doesn't have it, and then the ability to experiment disappears. It's a killer feature that causes us to run circles around compiled languages. One, because of its learnability and rediscoverability. It lets us exercise our own programs early and often. The interactive prompt can be pushed to extreme limits. So you can just use it for help and to quickly run your function. Or you can wrap something like use IPython or VPython, and it becomes an operating environment unto itself. And it is not uncommon to see a scientific programmer fire up an interactive prompt in IPython, load in data sets, visualize the data set in, using matplotlib, and to actively do all of their manipulations. They're not really programming so much as they're using it as a control panel to drive the ship from the command line. I think that's fantastic. And if you don't have an interactive prompt, you can't do that. The other thing you can do with it is you can embed it in a larger system. So it's a killer feature for a tool like Blender, where they list Python as one of their key success characteristics, where they've exposed all of the tools with Python as a scripting language, and you can either drive it directly, or you can experiment with the tools, or you can extend Blender using the interactive prompt. Who thinks that's fantastic? Do you appreciate it more now than you used to? I hope so. And then we often mention batteries included as a killer feature of the language. Start working with Lua, you'll miss your batteries right away. One of the things I've learned to do in my Python training classes is I show only a little bit of the core language, then immediately go to the batteries, so that people aren't, their first experience doesn't feel like when they learned programming in school. It's like, oh, I have to take this data type and shove it around and declare this and arrange this list. To some people, that seems meaningless and arcane and an utter waste of time and reminds them of the worst programming experiences they ever had. So I like to quickly take them out to, hey, let's load up some of the batteries and let's open up this file. It's got XML in it. And I say, I promise them, you won't have to touch a single angle bracket or even look at it. We'll just say, traverse the element tree until we find recipe/ingredients and then list all of the items. And then you end up with a 4-line long Python program that has parsed an XML file and extracted relevant information from it. Then we do something similar, pulling something down from the web and taking beautiful soup and parsing it up and generating some JSON and shoving it over to another program and firing up SQLite 3. The battery is included as a killer feature of the language, and I've learned now to lead with that instead of follow with it. I believe now the wrong way to teach Python is to save the batteries for last. It's where the power plays come from, and people are very impressed with it at the outset, and they walk away with a newfound respect for the language. So, who wants a language without batteries? Okay, so if you're inventing a new language, let's say you make something, take the first 2 letters of your company's name, this or go that, and you make this new language, what do you need to win? You need to build some batteries, and you need to build them quick. Okay, and then behind the scenes, what are we doing for you? We have a BDFL. He has made the language the way it is today. One of the things I like to teach early on is in Python is to not argue with the language. Python is Guido's language. He happens to be letting you use it, but it's his. So, sometimes the correct answer to a question is, why is this thing that way? Well, is a tuple just a crippled form of a list that happens to have some additional capability of being hashable? Is it an immutable list? Technically, yes. But the real answer is no. Why? Because Guido says so. Why is this important? Because Guido thinks of tuples as a holder for records, as a struct type in Python. So if you accept that and don't fight the language, if you program the Guido way, you program with the grain of the language. If you program with the grain of the language, you'll find that all the pieces fit together really nicely. Oh, every piece I grab just seems to already fit into the API of what I'm already working with. It's fantastic how Python just comes together like that. But someone else might be fitting pieces together and they never fit together. They're not programming with the grain of the language. Just a quick little anecdote. Who's ever played SimCity? All right. So there was some hidden logic inside that I thought was kind of interesting. I could play SimCity for a long time and just rarely get a tornado or a dragon or whatnot coming through my city. There are other people who, they could come play on my computer and right away they would be hit with the tornado every year. What were they doing wrong? There was a hidden rule in the game. If you were one of the types of buildings that would show up was a church, and in order to redistrict an area, you needed to bulldoze down what was there. He who bulldozed churches incurred the wrath of God. And not immediately, but later, you would get one tornado, one fire, one hurricane after another. Why is this important? If you program the Guido way, everything will just work for you. If you don't. Okay. One of our other success factors. We're going to get progressively more technical as we go along. Protocols. It sounds very technical. It's one of the things I think the language has done right and one of the things that is underappreciated. And there are some people in the audience who have contributed heavily to the things that Python has done right on this page. One is we make protocols. A protocol, is, in my mind, is essentially an API that applies to multiple tools in exactly the same way. It's fantastic. It's one of the things that makes Python easier to learn and fun to use. So there was a database API specification. 2 of them, as a matter of fact. DB API 2 is the current one. It provides a common interface to many varieties of SQL. It's fantastic. It is really nice to be able to switch versions of SQL and not have to change your underlying Python. Sometimes you have to update your select statements and whatnot to accommodate the dialect, but the Python interface is the same. It's fantastic. Learn once, write many. Hashlib. Use MD5. Later you can change the MD5 to a SHA-1, and you don't have to change anything else in your code. All of the hashlib operations all have the same API, which is kind of neat, given that they were written by different people at different times in Python's history. The protocols are working for us. Compression interfaces. We started out with an interface for gzip and zlib, but when xz goes in, guess what? It's going to be identical in its interface. It's fantastic. A lot of these things can be taught in minutes now instead of days because there is one protocol to bind them all. The conversion protocols. I teach Pickle. Say, here's loads and dumps. People have got that locked in their mind. How long do you think it takes me to teach the interface to JSON or Marshall? Not long at all. It takes seconds. Basically, it's the same thing as Pickle, but not Pickle anymore. Just a different underlying data format. Okay, a huge, 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 huge step forward for Python. What's the introduction of the WSGI protocol? Who knows how significant that? Raise your hand if you think that was just majorly significant to Python. Okay, those of you who raised your hand are those who remember how it was before. There were many, many, many web servers. There were many, 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 many web frameworks, and there still are. What's different is they didn't talk to one another. If you chose a web framework, it dictated and somewhat restricted your choices of web server. Or the other way around. If you had a web server, you had a limited choice of web frameworks. You couldn't switch. This was the one ring to bind them all. Brought them all together, a common interface. It was fantastic for Python. You do any sort of web development, whether you know about WSGI or not, you benefit from it every day. It makes Python awesome. And then lastly, there's things like the file API, the open, read, write, reline. That works for real files, string I/O. There's an amazing number of objects that follow exactly that API. And so Python is a language where I can teach a handful of APIs and cause people to learn most of the language as a whole. Who thinks that's fantastic? Who thinks it's awesome? Who thinks it's not like C, where all of the libraries were developed by different groups of people and had different notions of the interface? Every C library you picked up, unless it was developed by the same company, and sometimes even if it was developed by the same company, had radically different APIs or underlying context maps. You had to relearn how those people thought about the world, and heaven help you if you had to interface two different APIs. What did you do? The adapter pattern was born. The pieces didn't fit together, and you had to write an adapter for every two pieces you fit together. It's kind of like when a fish swims in water. You ask them the characteristics of water, they've forgotten. You swim in water every day and benefit from the existence of these protocols, whether you know it or not. It made Python much easier to learn, much easier to scale out. So, summary, these are high-level qualities of Python that I go into a management company and say, these are the reasons you should value Python. It's easy to learn. I can get your programmers up to speed fast. They'll have a rapid development cycle. There's an economy of expression. More importantly, not just economical, but it corresponds to the business logic. It's readable and it's beautiful, so your programmers will enjoy programming in it, and they won't hate you as much if they have to maintain someone else's code. Having one way to do it is a fantastic thing for Python. It means we can look at each other's code and not immediately have our jaw drop and our face twist in pain. The batteries included means you're productive right out of the box. Every distribution includes enough batteries to do powerful, effective things right away. The behind-the-scenes work we're doing takes care of you. Having it be Guido's language, having him make pronouncements, having it done in his image, unifies the language in the way that some other languages are not. Linux has benefited from Linus making decisions at the top. A number of tools have benefited from having a single person's vision implemented by multiple people. And lastly, is common protocols. Who thinks all these things make Python an incredibly awesome language? Okay. So a question arises. Could I possibly have been describing any other language here? Could I have substituted the word Python for Smalltalk, gone to a Smalltalk conference, and given most of these points? Some of them would apply. As I mentioned earlier, I think a lot of these other languages I mentioned are awesome and awesome in their own ways, and some of them are awesome in some of the same ways. So a lot of these apply to multiple tools. So let's get to things that are unique to Python, that is actually the core language itself. Ready for the technical part of the talk? All right. We're going to build our own language. We need to start with a foundation. What would Guido say the foundation is? One of the most important things to him, based on my conversations with him, is that the core objects are dictionaries and lists. Now, keep in mind I wrote sets, and I didn't include sets on the list, because dictionaries and lists are even more fundamental. Armed with just those, you can solve an enormous number of problems. It's one of those things where you can put dictionaries and lists in the hands of beginners, teach them how to navigate trees of dictionaries and trees of lists, and at that point they are as empowered as some computer science majors who've studied computing for several years. It is, if you're going to build your own language at a foundation, you need Dix and list. One of the reasons I loved awk, it had associative arrays back when nothing else did. I could get some of the power of dictionaries and lists available to me just like that. It's why awk was so expressive. Guido learned that from ABC. He brought it into Python. Next thing you need is automatic memory management. Ref counting isn't essential. It can be done with GC. The important thing is you're not doing specific mallocs and frees. Who's ever lived in that world for a while knows it's a very powerful tool. It's very fast. And it's also very painful when something goes wrong. So if you've never dealt with one of those languages, you really don't know how good you have it, but it's fantastic. And then exceptions. I was reading a follow-on to the Little Schemer, Little Lisper, and it was the second book. I think it may have even been written in the context of ML. And it argued that beyond all of the recursive capabilities, one of the greatest things that was ever added to that language was exceptions. Exceptions are the ability to do non-local jumps like a go-to or like a long jump, but in a structured way. It adds fantastic capability to the language where you can hop up to whatever, you can raise an exception and throw it up knowing that many layers up, it'll be handled by the thing that knows how to handle it without having to write convoluted, unstructured logic. It is a beautiful thing for a language. There are other ways to do it. My wife is a VB programmer. They have their own techniques, some of which allow resuming the code that raised the exception. So it's not a straight win, but it's a fine thing to add to the language. And then making things first class, like functions, so that you can pass functions as arguments. Who's ever read Joel on software? So one of his fantastic articles is, can your language do this? And he is talking about the notion of functions being first class and describes the compelling advantages of it. I recommend the article highly. It is amazing to me when my wife and I whiteboard some of her code. I think, well, wait, you can't do that in VB. You can't pass a function around. You can't create a new function on the things you can't do with the collection objects. It's just incredibly painful. It does have some other incredibly powerful features that are useful for her, but you really notice this stuff when it's gone. And then lastly, I don't know that everybody else would consider this to be part of the foundation, but I've done enough work with the core to know that really part of our success was overwritable syntax, that brackets correspond to under get item, dot corresponds to under get attribute, add corresponds, the plus corresponds to an under add. Because of this design, we're able to generate code that whenever it sees one of these pieces, executes one of the methods on the right, meaning that we put almost no intelligence inside the brackets, no intelligence inside the dot, no intelligence inside the plus. This is fantastic. It means that all the good stuff in the language is all done down at the level of individual objects. In fact, when new style classes came along, we took lots of things that were hardwired, like the old, that says minus 15. I have negative 15 minutes. Okay, so overwritable syntax, the significance of it is it dramatically simplified the implementation of the language. And as people in here who've worked on other implementations can attest, it probably simplified their lives quite a bit too. All the details are down in the objects. It's what lets you extend the language and customize it. I would say if you're building your own language, you need to have these 5 things in order to have a solid foundation. So those are our basic wins. Guido went out and grabbed some basic essentials that made Python usable back in 1990. Okay, it's true. Classes came slightly later. Classes were grafted onto the language, but long before probably most of you saw Python. So this is a solid foundation. These are things that give Python a tremendous amount of its power. So could we do any better with that context I've given you, with the readability, with the community, with this solid foundation of dictionaries and lists? We should have a winning language. Can we go further? And the answer is yes. This is about where Python was a decade ago, 12 years ago, right in that range. We've had some significant wins since then. We've done some cool stuff. We've stepped into some pace and brought you some great tools. Would you like to see what they are? I think one of the number one killer features of the language is the Iterator Protocol. It is the high-level glue that connects the language together. We have a long list of things that are iterable: strings, lists, sets, dicts, collectionaries, files, open URLs, CSV, readers, iter tools, yada, 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 yada. We also have things that consume iterators: for loops, primarily, min, max, sorted, sum, set, list, tuple, iter tool. Hey, wait, some of those things on the second list are on the first list. Are you saying I can take the output of one of these and feed it into another? Yes, and in fact, we can string them together. Some of the more impressive one-liners in Python really have to do with, I opened something up that was iterable, let's say that gzip file. I passed it to something else that handled an iterable. I can pass something into set, which I can pass to sorted, which I can turn to list, which I can hand to pprint, and do all of that in one line. And our goal in Python is not to fit things onto one line. Our goal is to make pieces that connect together easily. And we find that the glue that connects all these parts together is the Iterator Protocol. Sorted was not intentionally designed to make something that could flow into set or vice versa. But you can do set on an input and uniquify it, eliminate all the duplicates, and take the output of that and feed it to sorted. I think that's fantastic. Two tools that weren't originally designed to work with each other fit together neatly. It's iterators that do that. And if you start chaining them together, you realize, hey, these fit together a lot like Unix pipes and filters. You could be one of the many, many people who think, you're the first person who's had this idea. I'm going to reprogram Python to have pipes and filters type syntax. And it's actually not that hard of an exercise to do. The important thing is the same power that you get out of Unix types and filters, you also get out of the Iterator Protocol. I think it's one of its number one killer detail language features. Are you with me? Are you tweeting from the mountaintops? No. What is the most popular language feature? Arguably, it's list comprehensions, especially when teaching Python. People love list comprehensions. I think they're great. They were derived from a notation used in mathematics. They're very clean and beautiful looking. One of the challenges with them is it's easy to get carried away and have a hard time fitting it all in one line. But aside from the length issue, it's a very beautiful syntax. And it's much more flexible than the alternatives using map, filter, and reduce, where you find yourself importing the operator module and you do some rather awkward constructions to do expressions that are non-simple. If you're just mapping add across two vectors, it's not so bad. If you actually have to take a whole formula and map it across, it's really nice to be able to do that with list comprehensions. People love list comprehensions. I love generators. I think generators are the easiest way to write an iterator. Now, we decided that iterators were the glue that held the language together. Problem is, they're no fun to write. I make a class that is an iterator class. I have to define under iter. I have to define next. I have to do an init. Every time I do any interesting operation, I have to pull back my state variables and remember where I left off. That's no fun. These things that are no fun become trivial, easy to read, easy to write, and something I can teach to Python programmers on their second day of learning Python, and they can be writing generators. I think that's fantastic. What did it take to add it? Only one key word, the word that was yield. It was a fantastic addition to the language. And it has superpowers. When you've learned generators, you're like, okay, I can write iterators very quick. You can file it away. But if you're like Armin or Chris or a number of Alex, a number of Weisenheimers, you're like, no, it does something even more magical than that. These things freeze program execution whenever you yield. They remember all of their local variables. They remember their execution pointer, and they remember all of their open, I'm in the middle of a for loop, and I'm in the middle of multiple tries and accepts. It remembers all of that and is resumable. which leads you to say, hey, I can do all my cool computer science stuff. I can write coroutines. I can implement twisted inline generators. All kinds of fantastic capabilities ensue from its ability to remember its state and then resume later. Who thinks that's fantastic? It is not just a language feature that is pretty. It is a technological marvel, and we can thank Pippi for it. Okay. So, winning language feature. What is the logical love child of list comprehensions and generators? Well, it would be generator expressions, set comprehensions, discomprehensions. This is what Feynman would call ordinary genius. Any ordinary genius could have said, hey, I could take these two things and stick them together. One way or another, we were going to get there. It was obvious both things were very useful and needed to be married up. And so now we have this beautiful syntax for generators and sets and dicks. Okay, that was ordinary genius. What is extraordinary genius? Extraordinary genius is where you're not just combining together existing features. You're doing something new and wonderful. I think one of those is decorators. Decorators took a certain amount of genius because it was not obvious that it was the right thing to do for the language. There was considerable debate about it. There were a couple pieces of syntax floating around. Guido was convinced to put them in because a couple of tools needed them. And they did a lot of function and a function, function wrapping a function, wrapping a function type thing, and they really needed it for usability. And essentially, this was going to be a concession to them to simplify their particular problem domain. Some thought was put into making them a little bit more general purpose and hopefully usable outside. It has been a wonderful, wonderful addition to the language. They're expressive. They're easy on the eyes. Works for functions, methods, classes, and it adds a powerful layer of composable tools so that an amazing number of decorator tools have been written to where a person can add extra functionality easily to their program just by putting an @ sign and a decorator name before a class or a function. I introduced one in Python 3.2. So you write your Fibonacci function. It's a terrible example, by the way, but I like it because it's easy to demonstrate. And one of the worst ways to write the Fibonacci function is you return fib n minus 1 plus fib n minus 2, which is catastrophic in terms of performance. If you run that for fib 100, it will not finish in your lifetime. You have the power of Google backing you up, and you're splitting it across all their machines. So, how do you fix this? Well, you can rewrite the algorithm, but hey, that takes you away from the way it was described in the books. You've lost your little recursive relation. What if we just put one line before the function, said @LRU cache? Presto, it has instantly moved into the world of dynamic programming, caches previous results, and now when you say fib 100, it takes 101 iterations to complete and becomes astonishingly fast. Now I have a function that whose job it is to take someone's name, open a database connection, go out to the database, do a SQL search with the where clause, where equals that name, and return the phone number, then parse up the result, coerce it to an integer, and hand it back. That happens every time I look up the person's name, just to find their phone number. What does it take to optimize that? @LRU cache. At least recently used a cache. Decorators are a powerful feature to extend the language in a beautiful, readable sort of way. Who thinks that's fantastic? Cool. Who hasn't even heard of Python 3.2 yet and just wonders what this cache thingy is I'm talking about? If you feel left out, you could go look at the docs for it, and you will find a link to a version of it that works back on Python 2.5 and 2.6 and 2.7 and all those primitive Pythons that you're still stuck with. Okay, something we got that you don't got. My language has introspection and yours doesn't. It's a fantastic feature. If Alan Kay were here, he's very curmudgeonly. I had the pleasure of being able to work with him for a year. Anytime you would bring up something like this, we solved this problem back in the 1960s. Lisp did this. Lisp was introspectable. But then people forgot and made lots of languages that couldn't introspect. So it adds a capability that's off limits to statically compiled languages. It lets us build tools like inspect, PyDoc, help, meta classes, doc tests, unit tests that do self-discovery, debuggers, all kinds of wonderful things. If you are not introspecting in Python, you are not using the full features of the language. Who thinks this is a powerful, awesome capability that we got and you don't got? Okay. All right. There are those who consider exec and eval to be a sin. I am not one of them. Alan, would say it was a list killer feature. It was the ability to run itself. Python can run itself. So I will not try and convince you that it's awesome. I will say that we've used it in time. It creates code on the fly. Name tuples run themselves through eval. It's really a fantastic capability. I will point you to a recipe. If you go to search in the Python cookbook for spreadsheet or look at one of the top recipes there, it shows a simple way to use eval to implement spreadsheet-like capabilities in just a couple lines. It is fantastic because eval will accept as an argument not just a dictionary, but something that looks like a dictionary. And that something that looks like a dictionary can recursively go back in and do a chain of calculations. If you've ever worked with a spreadsheet, you'll know that it seems to be able to figure out a dependency graph. Whenever you enter a formula, it knows what it depends on. So if you change an input, only the things that depend on that input change. It's fantastic. We have that capability too. And if you haven't played with eval and haven't given it a custom mapping, you've missed out. Tweet it from the mountaintops if you think you just learned something new. Who learned something new? Everybody in here knew you could do that. I don't buy it. All right. One of our killer features is the with statement. I think this is a marvelous piece of technology. I have seen things like it before, but not many. Most languages are deprived of the with statement. So from the point of view of a person just using with every day, it's just a clean and elegant way to do resource management, to make sure your locks are freed up and that your files are closed, and that I put threads and locks in the same thing. I should have put files there. So it's a very elegant tool. But more importantly, it's a tool for factoring. So you have a piece of code A, B, and C, a sandwich. Now, in that sandwich, it used to be that the common problem was the thing that changed was the bread on the sandwich. Different bread, same meat every time. What was our solution to that? In the beginning, there was go sub and return. God gave us the subroutine. Subroutine was a way of handling the problem of different bread, same meat. The with statement is the other way around. Same bread, different meat. I have the same setup and the same teardown over and over again. It's just the body that goes inside that changed. So it is the inverse of the subroutine. So given that it's the inverse of a subroutine, or the complement to a subroutine, you would have thought that somebody would have thought this up a long time ago. And I'm sure they did, but they expressed it in some arcane form that no one wanted to use. So it died a horrible death. It now came back in a beautiful form, and it provides you an amazing tool for factoring, for implementing the dry principle of not repeating yourself. So who just learned the magical purpose behind with and why it was special? Who learned something new? All right. It makes really, everybody knew that it was the whole bread sandwich analogy. I don't buy it. Now, a tool that you never use but benefit from every day, abstract-based classes. Identify? Am I going slightly negative? I'm actually negative. Okay. So I will wrap up here pretty quickly. Abstract-based classes is the next to last one. And the thought here is the most important thing it did for us is prior to ABCs, the notion of what was a set or a mapping was a very vague concept. We had some general agreement among ourselves that it needed to have get item and link, and possibly if it had keys, it was a dictionary, but maybe not. Possibly if it had items, it had a dictionary, maybe not. You benefit now from, it is now defined exactly what it means to be a sequence and a mapping. And because it's exactly defined, you benefit from it every day without realizing it, because the parts fit together much better. So just having a definition was progress. Also, it gives you mixin capabilities. If you've ever used user mixin, you would know that it's the simplest way to give a full mapping API to your object. So you define get item, you define length, and you define keys. You pass it to user mixin, and you get the entire dictionary interface for free. It's fantastic. We've given you a lot of these capabilities through the abstract base classes, so you can just subclass them and very quickly roll your own fully compliant set class or mutable mapping. And then its last magical capability, change something fundamental to Python. Python was special because we had duck typing. Duck typing. It looks like a duck, walks like a duck, and quacks like a duck. It's a duck. Is anything else a duck? Well, yes, real ducks. Real ducks. What else is brown and floats? Okay. I have to throw in a Monty Python reference. The new duck typing says, if it says it's a duck, I have something here that doesn't look like a duck, walk like a duck, or quack like a duck, but it claims to be a duck. And I actually look on the duck list, and it is registered as a duck. Who put it on the duck list? It registered itself, and it said, I am a duck. That is the new duck typing in Python. And it gives you the ability to override is instance and is subclass. So it used to be a cardinal rule in Python. You never type check. Because as soon as you say is instance X of list, you are precluding X from ever being a list-like object that's not a subclass of list. You've tied the hands of people. But that's a segue into my art of subclassing talk, which is at the end of the week. Hint. Okay. So you have the ability to lie to his instance and his subclass. It's a brand new capability. And last winning language feature was the indentation. This is how we write our pseudocode. It contributes to the clean, uncluttered appearance. And for its time, it was an audacious move. Even now, there are people who come to Python and are shocked that our white space has significance. I imagine all of you have grown used to it. A quick thought is I used to follow SIG errors for the ACM, and one of the errors that interested me was when AT&T in the United States went offline for 8 days. They traced the error to a single line of C code. The C code lied about what it did, in part because of its indentation, and in part because a break was used to break out of a multiple level of if instead of multiple level of for and while. So this is heavily nested code. The indentation lied about what it did. The comment lied about what it did. And yet they knew this was critical code. And when they knew it was critical code, they had many layers of review. Lots of extremely smart programmers looked at this code and blessed it. And the code lied to them. So one of the lessons that was derived from that was the proper way to do these type of reviews now is, one, you strip the comments, and two, you run the C code through a beautifier so that the indentation doesn't lie to you. It actually reflects the real logic of what the program does. Do we know any language that does that for you? That's Python. The indentation never lies to you. It tells you what the program does. Who thinks that's fantastic? So, summary of winning language features. You got them all. Is that all that makes Python awesome? If you can think of anything else, I urge you to tweet it from the mountaintops. Yes, sir?
I just say modules.
They were in there.
We didn't mention them as a feature.
It's a major feature. Guido mentions inspiration from Modula. And
Please repeat the question for the audience.
yes. So I had not mentioned modules as a major language feature. It's one of those things you're like, well, of course you have modules, except for languages that don't have them. So Guido mentioned in his history of Python inspiration from languages that had a modular structure. And so that was an early feature of the language. Packages got added later on. In my opinion, they've been heavily abused, but modules are a fine thing. Any other awesome features I missed?
I have two quick questions. The first one is about the ease of learning. How do you think we can balance that with the necessity for language growth in the future? Second one is about protocols. The funny thing is that we don't have a formal protocol definition in Python, but they work anyway. A lot of people, even not in the batteries, if they have a file-like object, it will follow that protocol. So how much do you think these have to do with the nature of the community?
Okay,
protocols work because
of the second question was on protocols, and the first was on... Okay, so let me handle the protocol question first. Python doesn't have a protocol. I interpreted that in several different ways. And we mentioned file-like objects. Those actually have a definition too now. Abstract base classes were an attempt to define a protocol for that. So there is a protocol now for what it means to be a file-like object. So eventually we're getting those. How about a language definition itself? It used to be, Tim Peters said, the definition of Python is whatever CPython does. And unfortunately, to some degree, that is still true, but it is becoming less true, and hopefully it will stop being true altogether in the fairly near future. So we won't have an official spec, but we will have some agreed upon commonality between all of the implementations that it is no longer CPython. is no longer Python just because CPython happened to do thing X, possibly unintentionally and not by design. The ease of learning question really had to do with, at one time the language was very simple. You could learn the whole language in a day, the whole language. Python 1.5.2 is still cherished by many because you could learn it very quickly and know the whole language. People used to say it fits in my head. No longer does it fit in your head. I am shocked to talk to Python core developers. Routinely, they forget what's in the language. I talk to people who teach Python every day. They forget what's in the language. I follow on the little Twitter streak. I'll have Steve Holden, the head of the PSF, teacher of Python, propose features that are already there. It happens a lot. And so we have a challenge there of how to organize that information about what exists and to try to not expand the language without bound, to add features that unify rather than take away. And I think it's an ongoing challenge. Yes, ma'am? Oh, yes.
It's the only language with a time.
We don't talk about the time machine, and we way don't talk about the PSU, F. And we get to have some question that comes over the radio from the people upstairs in the overflow room.
Hello. I'm not going to mention an awesome feature. It's more of a kind of digression with readability and indentation and ease of use that he mentioned. It's more based on a personal story that today you can consider kind of anybody can program Python. It's because the much effort in making it easy. But that has a major drawback that anybody can program Python. So you go to an interview, you're reading the curriculum vitae, and the next question after reading that he programs Python is if he knows how to program. Because really, I once had to read some source code that this guy used one space for an if, and for the other if, he used 3 spaces, and obviously his functions span through 10 screens.
Would it be a fair recap of what you said, that atrocities can be committed in any language, and that Python, in a way, is worse because it's so easily acquired that people who have almost no programming skill at all...
No, I'm not saying that it's worse, but maybe the problem is this guy was working as a programmer, and I think... Please don't kill me for this, but if this guy had to deal with a compiler, he would have quit programming. I mean, for the good of all of us. I mean, he would have done something different. And that's what I mean.
Okay.
That sometimes
I will talk that up not as a question, but as an observation. If I were to hint to a positive direction, I'd say, in the interest of the awesomeness of Python, this person could possibly actually be trained to do amazing things. And there are people who come to Python without a modicum of skill, but eventually, with some time with Python, find that it opens doors to them to teach them some amazing things. So your buddy Raymond came to Python with a huge amount of programming, except in this area called the Internet. And so I opened up the essential reference over a decade ago, and I typed in the socket examples and whatnot, and I learned everything about the Internet through David Beasley's examples, and then only later reading RFCs and whatnot. So training can happen. Yes?
Just 2 questions. First, you didn't talk about the buffer and the memory views that's coming in 3. In Python 3. Like it's really important for NumPy and everything that's gone at the C level. And another thing was more of a question about what's going to be the next awesome thing about Python. I mean, what do you have in your pocket, basically?
So, 2 dramatically different questions. One was, I did not mention on the list of awesome things, a buffer protocol and the memory view object. Possibly because, in my view, they aren't awesome. Can be awesome, were incompletely implemented, and may someday be awesome. But amongst some of the core developers, we kind of vote amongst ourselves on what was the least useful feature in Python 3, the new feature. Possibly the memory view object was it. Yet it has the potential to be very important, because in the NumPy world, one of the discoveries was the ability to dance across arrays in memory in ways where you could specify a stride and the size of the pieces was actually an incredibly powerful, not metaphor, but a style of interacting with data, one that transcended the scientific world and was really a fantastic tool. And the idea of the memory view object was it was going to give everyone access to that. I believe it has not fulfilled its promise in that regard. And the other question was, what is the next most awesome feature coming up in Python? Alan Kay said the best way to predict the future is to invent it. And so it's up to you to make it. One that I put in was in Python 3.3. You do go to, we have daily builds. So you can actually be running Python 3.3 right now. So chain map is in there, which is the ability to take multiple mapping objects and link them together. The traditional style was you take a dictionary, you copy it, make a new one, and then do a whole bunch of updates copying dictionaries over, when in fact you can link several of them together. And it's an amazingly powerful technique. So that is one that I know of because I invented it. The other one, that the others that haven't been invented yet, I invite you to come invent the next best thing in Python.
Unicode strings.
Fair enough. Did you guys have a great time? Yeah. Is Python awesome? Tweet it from the mountaintops. No.
Yeah, two questions.
Two?
Yes.
Do it?
Yes.
No.
One about what do you think about strong typing? I think that Python is beautiful because I really like if I make bad things with the types, it kicks my ass. And the other question is why Python is case sensitive. I think that case sensitivity is a big deal.
I understand. The second question was why is Python case sensitive? He views case sensitive as a big deal. What's the standard answer? Because Guido said so. And how do we know Guido was right? It seemed to have worked out well for all of us who've been programming in Python for years. That being said, we've had to adopt some conventions because people have gone a little bit nuts. As Alex pointed out, being inconsistent in the uppercasing and lowercasing and camel casing and whatnot. So the, atrocities can be performed. Fire can be your friend or your enemy.
Actually, that's the consistent. S is not HTTPS.
Right.
It's consistent and wrong.
Consistent and wrong, which is the worst of both worlds. And I'm sorry, your first question? Strong typing. How do I feel about strong typing? Every language that I had mentioned is awesome. Some languages are more strongly typed than others. Each of them is awesome in their different ways. I love that in Python I can create a tracer class that looks like some other class, drop it into a function, and have it run through and inform me and log every activity that occurs along the way. That's a fantastic capability. At the same time, I also love OCaml. OCaml is fantastic because I get all the benefits of strong typing with almost none of the overhead. It's a different language and awesome in its own way. So strength or weaknesses, really, you just use each tool for what it's good at.
Okay, time for the next one.